So, we were talking about law of sines today. So, we did right triangle trig the past couple days, but you can only find sides and angles if you have a right triangle. But law of sines you can use for any kind of triangle. So, you can use law of sines for any type of triangle. Okay, so you can use it for a right triangle if you want to, but you can also use it for obtuse or for acute. Okay, but in order to be able to use law of sines, you have to have one side and the angle opposite of the side. Okay, so you must know, or you must have, the measure of, bless you, one side and the angle opposite of the side. In order to use the law. Okay, so the other day we were solving the triangle and we labeled it big A, little a, big B, little b, big C, little c. So you have to have one of those pairs in order to do it. So you have to know big A and little a, big B and little b, or big C and little c. Okay, so you have to have a pair of side to opposite angle. So right triangle trig is all about ratios, because it's based off of the similar right triangles having the same side ratios, opposite over adjacent, all that. Law of sines is also ratios. So let's draw a triangle. And let's label it A, B, and C. So we already said the other day that our angles are our capital letters, A, B, and C. And then the opposite sides are the lowercase letters. So if big A is here, across from it's little a. Big B is here, we got little b down here, and then big C across from it is little c. So, law of sines is based off of the ratio of the side to the sine of the opposite angle. So, what you're going to do is you always put sides on top and angles on the bottom. So, it'll look like this. So, little a divided by sine of big A. So, it's always sine. You're not having to decide which one to use. It's always going to be sine. That's why it's called law of sines. So it says the ratio of A to sine A is equal to the ratio of little b to sine of big B. And it says those ratios are also equal to the ratio of little c to sine of big C. So, on the top, you always have sides, and then on the bottom, you have sine of the angles. Okay, so you always put sides on top, And always, of course, angles go in the trig functions. And of course, we always use A, B, and C. It doesn't have to be A, B, and C. It could be X, Y, Z, or whatever. As long as it's capital and lowercase. Okay. Let's do one. So let's say we have this triangle. And let's say we have the bottom two angles are 75 and 30. And our opposite sides are X and 15. So, to be able to do law of sines, we have to know a side and the opposite angle. Well, if I look at this, I know the side 15. Do I know the opposite angle? Yeah, 75. So that's my only requirement to be able to do this. So now we can set it up. Our side goes on top, so 15 divided by sine of 75 equals. And now we're trying to find this side of X, and it's opposite of the 30. So our other ratio is X over sine of 30. Okay, so sides on top, angles on the bottom, and you're always setting them up where they're opposite of each other. Questions? So, does anybody remember how to solve a proportion like this? Yeah, so we just cross multiply. Boop, boop. So that'll give me X times sine of 75 equals 15 times sine of 30. So you can go ahead and do the 15 times sine of 30. I always wait and type it in all at the same time just so we don't lose any decimals, but either way is fine. So our goal is still to get X by itself. So how could I get rid of this times sine of 75? Get divide. So we divide both sides by sine of 75. And then we just type that whole thing in our calculator. Of course, you still want to be in degree mode. And so we go 15 sine of 30. You do have to close your parenthesis after that 30. And then divided by sine of 75. And hopefully you get 7.76. What? Did you close your parenthesis after the 30? Are you in degree mode? So you still want to be in degree mode. Really, anytime you're doing something with triangles, you want to be in degree mode. Any questions on this? Alright, let's do one where we're finding a missing angle. So let's say we have another triangle. We have this top angle is 89.5 and its opposite side is 50, and we want to find big A, and its opposite sine is 31.5. Okay, so our only requirement is that we know a side and the angle that it's opposite from. Do we know that? Yeah, because we got the 50 and it's opposite of the 89.5. So we can use that one. So we put the side on top, so 50 on top, divided by sine, it's always sine, of 89.5. Equals. Now on this one we're trying to find A, which is the angle, but I know across from it little a is 31.5. So that's my side, so it goes on top. But I don't know big A, that's what I'm trying to find, so it's just sine of A. Any questions setting it up? Alright, so just like our last one, we want to cross multiply. So we get 50 sine of A equals 31.5 sine of 89.5. So this one has a few more steps than our last one because the A is inside of that sine. So I know I'm going to have to do inverse. But before I can do that, I have to get the sine by itself. So how can I move the 50? Good. Divide. And then again, we can type that whole entire thing in our calculator. So 31.5 sine of 89.5. Again, you have to close that parenthesis. Divided by 50. So hopefully you get 0.629976, etc. So you want to keep as many decimals as you can, just so you don't have a whole lot of round off error. But now sine is all by itself, so to get rid of sine we do inverse sine. So sine to the negative 1. Now, if you don't want to lose any decimals at all, what you can do is you can type second sine, and then to get that whole entire decimal, that's your last answer. So if you hit second negative, it always plugs in the last answer that you got. So that way we don't have to round or anything. We get the most exact answer that we can, which is about 39.05. Questions? All right, let's do one more. Okay, so let's say we want to solve the triangle. What does that mean? Good. So we want to find all of the angles and all of the sides. And let's say it tells me that big B is 102, little a is 15.7, and little b is 18.4. So for every single triangle, you have 3 sides and you have 3 angles. So in this one, it gives me 2 of the sides, so I still need 1 side, but it only gives me 1 angle, so I need 2 angles. So I need to find big A, big C, and little c. So it always helps me to draw a picture. Some people can do it without drawing a picture. If you can, that's fine. But I always want to draw a picture just to keep track of everything. So again, it don't matter where you put A, B, and C as long as you match the opposite sides. So I'm just going to say A, B, C. And then across from, of course, we have our littles. So little a, little b, little c. Then we can plug in what we know. So I know big B is 102. I know little a is 15.7. And I know little b is 18.4. Bless you. So if we're looking at this, in order to solve them, you have to have at least one piece of the ratio. So I don't know anything about the C's yet, so I can't do anything with them. But I do know little a, so I can find big A just like we did on the last problem. And I already know big B and little b, so that's the ratio that I want to start with. So little b is 18.4 divided by sine of big B, which is 102. So then if I'm looking for big A, opposite of big A, little a is 15.7. So 15.7 divided by sine of big A. And then it's exactly like the last one, so you want to cross multiply is always your first step. So we get 18.4 sine of big A equals 15.7 sine of 102. So we are going to have to do inverse, but only after we get the sign by itself. So we have to move that 18.4. So we divide. So again, you type all that in your calculator. just make sure you close your parentheses after the 102. And so we get this decimal. And then again, we want a by itself. We got to get rid of that sign. So we have to do inverse. And to avoid our round off error, you can do second sign. And then as long as the last thing you typed in was all that, that's your last answer, second negative. And so we get about 56.58. Any questions on that? Okay, so that is our A, 56.58. But if I'm looking at this, I still don't know anything about either of those C's. Could I find either one of the C's based off of what I know so far? Yeah, big C, because why? Good, because all of our angles in the triangle add to be 180. So I can say big C equals 180 minus 102 plus 56.58. Okay. So don't even have to do trig on that one, just having your knowledge of triangles. And so hopefully you get big C is 21.42. Questions? Okay. So now we can find little c. We know pretty much everything else about this triangle, so you could use big B and little b, or you could use big A and little a. It doesn't matter. You'll get about the same answer. I'm going to use B just because we didn't round at all on that one, so it'll be a more precise answer, but either way it doesn't matter. So we get 18.4 over sine of 102, so same ratio we used before. But now we're looking for little c, and it's a side, so sides always go on top. So little c over sine of 21.42. And then we cross multiply. So we get little c sine of 102 equals 18.4 sine of 21.42. And finding a side doesn't have as many steps as finding an angle, because all we have left to do to get c by itself is just divide by sine. And then we're done. And again, you can type all that in at the same time as long as you close those parentheses. So 18.4 sine 21.42, close them, divided by sine of 102. And so hopefully you get 6.87. Questions? So hopefully not too terrible to solve. Just some ratios.